Hi everybody. Today we're going to talk about critical values. And to understand what critical values are, it's actually pretty simple. Alright, let's just say we have a graph like such. Okay, move it out of the way. And on it, let me just do one thing. No grid. Okay. And let's just say you had a graph that did, something like this, and maybe that, and maybe went on ups like so. Okay. Now what critical values are the places where the tangent line is either 0 or non-existent or undefined. Okay. For instance, here if we were to draw a tangent line, would be 0. The slope of the tangent line would be 0. The same goes for this spot and this spot. But notice here, the derivative is non-existent because it comes to a sharp point. That is still a critical point. Okay? Now I want you to notice some other things that happen at critical values, and we're going to be talking about this in a day or two. That we have a maximum here at this critical value, and we have minimums at these critical values. And this one, even though the derivative does not exist here, is still a maximum value. Okay, these are considered your relative maximums and minimums of this curve. So our goal today with this video is to find out how to figure out what the critical values of a function are. Okay, it's really not that hard. Here's how you do it, or the rule for it. Okay, to find critical values, all you do is find where f prime of x equals 0 or where f prime of x equals d in e. Okay? So our critical values occur where the derivative is equal to 0 or where it is undefined. Okay? So even give yourself that note if you wish. Critical values occur where the first derivative is equal to 0 or undefined. Okay? So that's what we're going to do, is we're going to find some critical values on a few problems following those guidelines. All right? So click. So here we have a problem. We're going to take its derivative. So we say, because remember it says where the first derivative is undefined or equal to 0. So we take the derivative. Now I'm going to introduce a new derivative form for square roots, and it's something you should kind of get in the habit of using. I know most of you would change this to the 1/2 power, then take the derivative. But really, if the easiest way to do it is look at it as u prime over 2 root u. And that only works for square roots, but it's a great way to deal with problems like the ones we're going to work with. Okay, so we do u prime, which is the derivative of what's underneath here. So that would be negative 2x over 2 times the radical 2 minus x squared. Of course, you simplify, and you get negative x over the square root of 2 minus x squared. Okay? So the reason I set it up this way and use this particular formula is that it's very easy to see where this will be equal to 0 and where it will be undefined. If you take a look at it, the numerator is the only place this guy will be equal to 0. So for that, you just say, okay, well, x has to equal 0 then. But the undefined region, remember, this zone makes it undefined. Okay, so what we do here is we also set that equal to 0 and solve. And if we do that, we get x equals plus or minus radical 2. Okay, and that kind of makes sense for us because if we really look at this shape, this is actually a semicircle. Okay, so if we were to graph this shape, it would look something like this, okay, where this would be the square root of 2, this would be the negative square root of 2, and this would be where you have that horizontal tangent line, okay, at x equals 0 here. So it's just something to think about as you do these, that the reason it's undefined here is because you actually have vertical tangents here, and that's what makes it undefined. But you say your critical values are x equals 0 and plus or minus radical 2. And that's the answer to the question. Okay, well, let's try a second one. Ooh, this looks kind of tough, doesn't it? Well, let's see. Remember, take the derivative and set it equal to 0. So we have 6x squared minus 6x minus 12. Okay, so the rule is it's where the derivative is equal to 0 or where the derivative is undefined. In the previous question, we had both a location where it was equal to 0 in the numerator and where it was undefined in the denominator. Usually, when you get denominators, is the only place it will be undefined. Here, will it ever be undefined? No, you're correct. Okay, the only way you can get critical points then is for it to be equal to 0. So that's what we do is we solve now this little quadratic, and I'm going to start by just dividing out the 6, and that gives me x squared minus x minus 2 equals 0, and then it's factorable, x minus 2, x plus 1 equals 0. So that means you have a critical point at x equals negative 1 and x equals 2. And those are your critical values. Not bad, huh? Well, good. I'm glad you agree. Let's try one more. Now, this is a multi-rule function. Is there anything different about this other than it being a multi-rule function? No, the rule still applies. Critical points occur where the derivative is either undefined or equal to 0. So what we're going to do here is take the derivative of this guy. And when you take the derivative of a multi-rule, remember, you just take the derivative of one part at a time. So this would equal 2x, and this would equal 2, comma, x greater than 0, and x less than 0. Okay? Now, let's talk about this. Where will this be equal to 0? There's only one in one location, and that's when x is equal to 0. Okay, but notice here in our derivative, all right, wait a minute, Mr. Engel, x can equal 0 according to this. Aha, that's correct. But what's really happening in this graph if you actually take a sketch? All right, what it looks like is something like this. Here you have the x squared minus 1 component as a parabola, and here you have the 2x minus 1 component coming up and meeting it right here. Okay, so even though you have different slopes and the derivative doesn't exist, at x equals 0, a critical point still exists. Okay, however, is that critical point either a maximum or a minimum? No. Okay, it's just the derivative is undefined at that point because the derivative is dne at that value. Now, sometimes you have to understand that with multi-rule functions, at this point here, you can have undefined values for your slope. Therefore, you will have a critical point there. So you have to be careful with it. Okay? All right, that's the wrap. Hope you all enjoyed the video. We'll see you in the morning. Stupid video won't stop.